Centrifugal pump tutorial question number 5. Determine the torque and power output for the turbo machine shown below. This is the data for the pump. Outer radius 300 millimeters, inner radius 150 millimeters, flow rate 0.057 meter cube per second, speed 25 radian per second, and density 1000 kilogram per meter cube. In this question, we use speed in radian per second unit. From the diagram, we know that the velocity 1 is equal to 3 meter per second and velocity 2, V2, is equal to 6 meter per second. So, from the diagram also, we could say that the outlet velocity angle is 30 degree here and angle inlet velocity is 90 degree here because it says that the flow here is radial. So first, what you need to do is you need to draw velocity triangle very well. In inlet, this is the velocity triangle, and at the outlet, this is the velocity triangle. Please start your velocity triangle with absolute velocity V1 and absolute velocity V2. Torque for pump can be calculated by using this equation. T equal rho Q V whirl 2 R2 minus V whirl 1 R1. From the diagram, we know that V whirl 1 is equal to 0. We could calculate the value of V whirl 2 by multiply V2 and cos 30 degree. So we have 5.196 meter per second. We substitute all the value here. We could get torque is equal to 88.85 Newton meters. And to calculate power for pump, the equation is P equal rho GQH. We do not know what is we don't have any information about efficiency, so in this question we assume that H is equal to Euler head. We could calculate the value of U2 here by R2 omega, and it is equal to 7.5 meter per second. Then we could calculate the Euler head by using this equation, and we get 3.9725 meters. And to calculate the power, we substitute all the value into this equation. We could get it is 2.22 kilowatt.